the central limit theorem for proportions. In order to apply the central limit theorem for the proportion, we first need to check the condition. The first condition is n times p greater than or equal to 10 and n times 1 minus p greater than or equal to 10. The distribution of p hat is approximately normal with the mean, and the standard deviation is mu of p hat equal to p, which is the population proportion, and the sigma of p hat is equal to p times 1 minus p divided by n, and we take the square root. So now let's look at the example number 1. First of all, we need to write out the notation for the number. 27%. 27% for American people who like chocolate for ice cream flavor. So that is talking about the whole American people. That is the proportion, because we see the percentage 27%, so that means the proportion. The proportion for population is 0.27. If a sample of 100 Americans is taken, so 100 is the sample size, that is n. What is the probability that the sample proportion of those who prefer chocolate is greater than 0.30? You know that this problem is the proportion. We will apply the central limit theorem for proportions because we need to check the two conditions first. But anyway, the key word for us to recognize is the word proportion. In section 7.3, we recognize the word is the mean. In this section, we recognize the word proportion. In order to apply the central limit theorem for proportion, we first check the two conditions. Number 1 is n times p. So n is 100 and p is 0.27. We get the answer is 27, and this number greater than 10. Another condition is n times 1 minus p. So n is 100 and 1 minus 0.27. We got the answer is 100 times 0.73 and is equal to 73. Is greater than 10 also. So then we can apply the central limit theorem. Before we apply the central limit theorem, we need to calculate the mu of p hat. So this is the mean. And this is the sample mean for the proportion. Is equal to p, and p is 0.27. Then we calculate the sample standard deviation. The notation is sigma of p hat. And the formula is square root of p 1 minus p divided by n. Square root of 0.27 times 1 minus 0.27 divided by 100. We calculate this number and we got the answer is 0.044396. And then we begin to draw the normal curve. So before I move on, let's go back a little bit. These two things right here, that is for the central limit theorem. Okay, now we will begin to draw the normal shape. And then the proportion is 0.27 is the mean proportion. So P or mu of P hat is right here. 0.27. And the question asks us point 30. So point 30, the location of point 30 is on the right side of point 27. We will draw the line. And because the problem says greater than, so we will shade on the right side. Our job is to find the area that is the probability that is greater than 0.30. And 0.30 is the sample proportion. The notation for that is p hat equal 0.30. We will refer to the z table. The formula to find the z is z equal p hat minus mu of p hat divided by sigma p hat. P hat is 0.30 minus 0.27 divided by 0.044396. We got the answer is 0.68. We notice that we need to take z for 2 decimal places. And then we look at the z table. We would use 0.6 for the column, and for the row, we will use 0.08. We map this number together, and we will get 0.7517. But you know that the z table provides us the error to the left. We want to find the error to the right. So the number that we just got, 0.7517, it means the one on the left side. But we want to find the one on the right side. Then the answer for the probability that is greater than 0.30 is we will subtract from 1. And we get the answer is 0.248.